Okay, so this should be 9.1 part 2. So the previous day, what you would have worked on was solving for unknown sides of triangles, of right triangles, okay? And then you did some homework on that, hopefully. That might have taken a day or two. And now we're rolling on to the next part in this chapter, which is going to be word problems. Of course, we can't have a good chapter without some good word problems. So, all right, so 9.1 part 2. Here we go. Okay, so and all those homeworks you did previously, make sure you hold on to those. I'm going to check all those when I get back. So we'll have like a massive homework check when I get back. So, all right, let's take a look here. We got the Grand Canyon. All right, so here's the word problem. While standing at, yeah, okay, it's Yavapai Point near the Grand Canyon, you can measure the angle 90 degrees between Powell Point and Windforced Point. Okay, so as shown. So you can see the picture right there. It kind of describes what's going on there. When you walk to Powell Point and you measure the angle is 70 degrees between the other point across the side and there. Okay. So what they want to know is, and they know that it's about 2 miles in between. So what they want to know is how wide is the Grand Canyon between those 2 points. Okay. So let's see if we can figure that out. All right. So yeah, a lot of words there, but the good thing is they gave you a nice picture. So the picture will end up being really helpful. Let's move this down, give myself some more room here. Okay. All right. All right. So here we go. We got a point here, we got a point there, and a point there. So it's a triangle, and it's a right triangle. Okay. And we're looking for this distance x. So let me highlight it so you can see what we're looking for. We're looking for that x, and we're given that. All right. So just take that word problem kind of way and solve it like regular. So if I were to take this, it would be the same triangle as this, right? Let me get my little triangle thing out here. Right triangle, and we know it looks like this. Comes down. Oh, it wants to do a triangle like that. I don't want to do that. Let me undo that. All right. So my triangle looks like this. I'll just draw it. Straight across and then up. Okay? So take that triangle, drop it down here, and this is a 90. We know this distance is 2. This angle is 76 degrees, and we're trying to find this distance right there. Okay? So we're just solving this triangle. It's just a regular um, trig ratio here. So if you look at it, what are we given? You always got to ask yourself what you're given. Well, right now we have the 2 and we have the x. So that's the size we want to work with because we don't know what the hypotenuse is yet. Okay, so let's label what we do know. This is the adjacent, ADJ. This is the opposite, OPP, because it's opposite of the angle I'm going to use, 76 degrees. And this is my hypotenuse, okay? So which one is going to use opposite and adjacent? So is it the SO, the KA, or the TOA? Hopefully you saw it right away that the TOA is what we need because look, we got adjacent, we got opposite. It's the only one with the O and the A, so that's what we're looking for. Okay, so we're going to use tangent. That's what we want. So the tangent of 76 degrees is going to be equal to the opposite, which is x, over the adjacent, which is 2. And now we're going to solve this just like we did yesterday. So to solve this, we're going to multiply both sides by 2. What that does is cancel it, which makes it really nice. So you get x equals 2 times the tangent of 76 degrees. All right, well, that is just simply a calculator problem. So let me um, open up my calculator. I thought I already started it. Maybe I didn't. Ah, shoot. We're going to have to wait on that a sec. So that's going to open up, and we'll punch that in our calculator to make sure. So again, so a couple pre-tips for when you're doing your calculator. Make sure it's in degrees, okay? Make sure it seems like a reasonable answer when you're done. If it's not, then you'll probably get an unreasonable answer. So let's let this load up for a sec. Sorry about that. I already had that up. And we'll give that a shot. And then you'll do a little extension to this question on the next slide. So let's see. Hopefully everything's going good. Okay. Miss T can help out with anything you guys are a little bit confused on. Okay, I got it up. So here we go. I'm going to type this in. Okay. So in case you forgot how to type this in, it's just 2, get to a calculating screen. So 2 times tangent 76 degrees. Enter. There you go. 8.02. Okay, so we'll just call it 8, about 8. So x is approximately 8 miles. Okay, so that means, relating it back to the problem, this distance right here is 8 miles. About. It's a little bigger, right? So there you go. It's just a regular, trick. So where you might be able to use it in real life sometime. Okay, the next problem. Okay, this one is all you. So take a look at this. Go ahead and pause the video now, and you are going to try this on your own. Okay, I'm back. All right. So hopefully you tried this. You hit the play button again, and now we're going to try this. We're going to try to find the distance between Powell Point and um, yeah, that wind forced point. Okay, so if you think about our triangle from the last slide, we had a right angle here. We know this distance is 2. This distance is about 8. Okay, and this angle is 76 degrees. So what we want to do now is find x. Well, there's a couple ways you can go about doing this. You could take Pythagorean's theorem and do a squared plus b squared equals c squared and solve that way. Hopefully some of you might have done it that way, but I think the better way here is to use sine again, or not use sine, but use a trig function. If we know this is 2 and it's an actual 2, or this isn't really 8, it's an approximate 8. So if I know an actual 2 here, and I'm trying to find this, and I know this angle is correct, so what am I working with? I'm working with adjacent, and I'm working with hypotenuse. Which one uses adjacent and hypotenuse? Ah, good answer. Yes, it's the cosine. Okay, so the cosine of my angle, 76 degrees, it's going to be equal to adjacent, which is 2, over my hypotenuse, which is x. To solve for this, it's very easy. You just multiply both sides by x, because I don't like that fraction. Okay, so those x's are gone. I get 2 is equal to x times cosine of 76 degrees. And then I'm simply going to divide by cosine of 76 degrees to get x by itself. So I have to do it on both sides. So there we go. These cancel. X equals 2 over cosine of 76 degrees. I'm sure I probably just flew there, but you gotta remember I'm doing this by myself. So okay. All right. Let's find out what that is. Oops. Oops. There we go. Okay. So 2 divided by cosine of 76 degrees. Enter. Bam. 8.26. Okay, so we'll just call it x is approximately 8.26. Okay, so that sounds about right. Was it 2.267? So really, if we're getting particular about this should be what? 2.7, because that rounds up. That's a better answer. So there you go. Hopefully you got that. How many of you got that? Put your hands up. Ah, very good. Or maybe not very good. It depends. Okay, so moving on to the next problem, okay, or next idea. Next thing we're going to be working with here is angles of depression and elevation. So common thing that pops up in word problems. So it's very easy to understand. Think about this being you. Let me draw you. Here you are. Oh yeah, very nice. Nice hair. Okay, that looks good. That's you. All right. If you're standing on the ground right here and you're looking up to the top of this building, this angle right here is the angle of elevation because you're looking up. Now, let's switch it around. Let's say that you were up here. Yeah, let me do it in a different color. Let's say you were up here in blue. Okay, now you're the blue guy. All right, oops, you don't have a head. That's okay. And you're looking down, right? If you're looking down, this angle is the angle of depression, okay? So this angle in blue is the angle of depression. So where your ground would be, down would be the angle of depression now. So there you go. Don't confuse it with this angle. This is not angle of depression. So you got to be careful there. That's the most common mistake. That is not the angle of depression. This is, okay? In blue is and green is not. Okay, so yeah, the formal definition's up there if you want to write it down, but I mean, I think it just makes more sense to look at the explanation. Okay, let's move on. So, elevation depression. So, parasailer is attached to a boat. These are lacking pictures. Let's put a boat here. Here's my boat. Yeah. Yeah, there's your boat. Parasailer is attached to the boat, and here's the little guy up here, right? He's got his little, yay. Okay, so there's a parasailer up there, and there's the boat. I guess it wouldn't be a sailboat. That doesn't really make sense, but that's okay. You get the idea. All right, and there's 30 feet of rope. So here's the rope in green, right there. Okay, and we want to know, and we know this is a 48 degrees. They tell us that because it says the elevation is 48 degrees. Okay, so estimate the sailor's or the parasailer's height above the boat. So we're looking for this h value right here. Okay, so what is that going to be? We got a right angle right here. That's my angle. So this is my OPP, my opposite. That's my adjacent. That's my hypotenuse. And now all I have to do is think which one's going to use the hypotenuse. You know, get a highlighter. Which one's going to use the hypotenuse and this thing? Well, O and H. Which one has O and H? Ah, sine function. Exactly. So sine, right? Because it's so. O H. Okay. Sine of 48 degrees is going to be equal to H divided by 300. Well, this is going to be an easy one to solve. All I have to do is multiply both sides by 300 and voila. Okay. These will cancel. H is going to be equal to this. So let's type this in the calculator and see what this is. So 300, okay, 300, okay, times sine of 48. Trig, sine 40. Oh no, I hit sine inverse. I don't want to do that. All right, sine of 48 degrees. Close it. Yeah, we should be good. All right, enter. 222.9. So 222.9. That's going to be my height. That's my height right here. Okay, so this is 222.9. Okay. All right, great. So that's how we do a little parasailing action. Okay. Now, I think we got a little spin-off for you. So here's your spin-off. What if the example in number 6, okay, the one we just did with the parasailer, had the height of the parasailer above the boat was, if the angle of elevation was 38 degrees. So, same situation. Let me draw you a picture. You know what? You figure it out. I think you got this. All right. So look at that problem, pause the video, give it a shot. Okay, and we're back. Hopefully you hit the play button again, and I'm hoping you drew a picture, okay? Hopefully you drew a better picture than me. You know, you got your boat, speedboat. What does a speedboat look like? I don't know. Little speedboat. Propeller. Okay, speedboat. Little glass up there. Okay, that's my speedboat. Guy on the parasail. The thing, you know. All right, parasail or speedboat, you get the idea. Now, what changed this time is the angle of elevation, which is 38 degrees now. Hopefully you drew that. We know the rope is still, how far was it? It was 300 feet. The rope is still 300 feet, okay? We want to know, what is that? Okay, we want to know how high above the boat. So, again, that's sine. So sine of 38 degrees is going to be equal to x over 300, okay? Multiply both sides by 300. That gives you, these cancel. X equals 300 times the sine of 38 degrees. Okay, type that in your calculator. Put this over here. So 300 times sine of 38 degrees. Enter. 184. All right, so x is equal to 184.7. How many of you guys got that right? Hands up if you got it right. Oh, very good, very good. I know you guys are so smart. Okay, so now moving on. You know what? That might be the last one I have for you today. Let's see. Oh no, I got one more. This is a good one too. Okay. All right. So here you go. You can see the situation. You got a plane up there, right? You got two towns. It's town A, town B. Okay. So you got town here, town there. Okay. You're up in the plane. You're looking down. You realize of um, the angle down is going to be 15 degrees here and 25 to the first one. So it's 25 to the first one, it's 15 to the third one because it's further away. What they want to know, what is distance D, okay, from the airplane to the first town? Let's see if we can figure that out first. So if you're looking at this problem, um, draw another triangle. That's the easiest way to do it so that the word problem's not holding you up. We know this is 25,000, okay? We know that we're trying to find, what are we trying to find here? We're trying to find D, which is this side. We're trying to find D right here, okay? And what do we know about its angle? This is where you got to be careful, okay? So if this is 25 to here, what does this angle have to be? Think about it. 90 minus 25, right? Well, so that's going to make it a 65-degree angle. So this is 65 degrees to the first line. So that means this angle is 65. Okay, that's a 90 right here. And we can find that, but I don't even know if I need it. Okay, well, if I'm looking here, that means this is my opposite, OPP. This is my um, adjacent, ADJ. And this is my hypotenuse, HYP. Okay, so let me give myself a little more room. Which function is going to use opposite and, well, no. You know, let me take that back. We're not using opposite, are we? What are we using? We're going to use um, adjacent. That's a sideways ADJ, okay? And hypotenuse, because that's what we want to find. So adjacent and hypotenuse. Which one uses that? Cosine. Very good. So cosine of 65 degrees is going to be equal to the adjacent, which is 25 with three zeros, all divided by d. Okay, so I'm going to solve for d. To get d by itself, I'll just multiply it on both sides. So d, so these cancel. I get 25,000 is equal to d times cosine 65 degrees. Divide both sides by cosine of 65 degrees. Okay, that means d, because these cancel, is equal to this. Oops. Okay, that's what d is equal to. Let's type that in the calculator, see what we get. 25000 divided by, divided by, hey, divided by cosine of 65 degrees. Enter. I got 59,155. All right, so let me extend that out. So D is 59,100. Oh, shoot, I forgot. 155. Okay, so there's your D. What does that mean? That means we found this guy right here. We know that distance. That's nice. Okay, so why don't you try B and C on your own? So go ahead and pause the video, try B and C on your own. Okay, I'm back. Hopefully you tried B and C on your own. Let's see if you got it right. All right, what is the horizontal distance x from the airplane to the first town? So from the airplane to the first town. Okay, so we're looking for this distance right here that I just underlined. Okay, we're looking for distance x. So All right, well, that's not too bad. You could do Pythagorean's theorem if you wanted to. Let's use the same triangle I had. All right, let me switch colors. I know you guys don't like that green. All right, so if I come over here like this, I know this distance is 59155, and I know this distance is 2500. Oh, that didn't write right. Yeah, it's close. All right, so this is a square, or that's a 90. This is 65 degrees, and then we want to know what this is. You could do Pythagorean's theorem. This squared plus this squared equals that squared. I don't want to do that. I'm just going to do the sine function, okay? Or maybe cosine, okay? Or more, maybe tangent, right? So let's see which one we want. Okay, so I got him and him. Or I can do him and him. I can go any way I want. I think I'm just going to go tangent though, okay? So this one I have opposite and adjacent, so that's going to be tangent of 65 degrees is equal to x divided by 25000. Okay? Well, that looks cool. All right, so we'll multiply both sides by 2500 or 2500. No, 25,000. Let's try that again. Multiplies both sides by 25,000. These cancel. Okay? So I get x is equal to this. Let's find out what this is. Okay? So, calculator. Okay? What am I at? 25000 times tangent of 65, enter. I got 53,612.7. All right, 53,612. So 5361, shoot, 2.7. Okay, so there you go. That's your B. That's the answer to B right there. So now we know, going back up here, we know this distance as well. Okay? So the part C, which hopefully you tried. If you haven't, pause it, try it now. Okay, part C, it says, what is the distance y between the two towns? Explain the process. Okay, well, all right, let's see if we can figure this out. If we already know the distance for x, and we're trying to find the distance for y, we're going to have to go back to another triangle of some sorts. So I don't know how to find y in that skinny little triangle like this. Let me show you what triangle I'm talking about. If I'm talking about this triangle right here, I cannot find y with that triangle I just highlighted. Okay? What I'm gonna want to do is find the triangle here. I'll do it in pink. This triangle. I find the big triangle. If I find this triangle, I can just subtract what I found for x, and I'll be left with y. Okay, so what are we going to do to find that? So let me take that highlighting off so I can see what the numbers are, and we'll go from there. All right, so if this degree is 65, and then this little piece right here is going to be, well, another 10 degrees because this is 15 and that's 25, so the difference is 10, so that's 10 degrees. So it's going to be 65 plus the 10, which is going to make it 75 degrees. All right, so we got another triangle. Let's come down here. So this is part C. We got a triangle that looks like this. This is 75 degrees. I'm looking for this full distance. We'll just call this full distance. We'll call it Z. Okay, and this is still 2500. Okay, so that's going to be the all right, so that's going to be opposite over adjacent, which is going to be tangent. So tangent 75 degrees is going to be equal to Z, which is what I'm trying to find. I'm just calling it Z. It doesn't matter what you call it. Over 2,500, or geez, 25,000. Multiply both sides by 25,000. These cancel, and I'm left with Z is equal to this. Okay, so let's type this in the calculator to figure out what that is. So 25,000 times, all right, so I kind of got it right here. All right, but I want 75. All right, hit enter. All right, so I got 93301.3. 93301.3. 93301.3. 0.3. So that's the distance. Okay, what does that mean? That's the distance. Let's go back up to the top. We'll talk about what that is. That is this distance right here. Let me get a highlighter. I'll tell you what we just found. That's this distance, that 933.103 or whatever that was. Okay, we just found that distance, but I don't want that distance. It says I want the distance y between two towns. So I need to take the total distance. I need to subtract what I found for x. So it's going to be y, all right, in our problem, it'll be y is equal to z minus x, where z in our case is 93301.3 minus what we found for x, which is, let's see, x is right here. Okay, so 5, 53612.7. 53612.7. So just do that in the calculator real quick. Okay, so I want this value right here. No, I want this value right here highlighted minus this value right here. Oops, right there. I hit enter. And what do you know? I get 39688.6. 39688.6. So 39688.6. And that's my value for y. And you're done. Okay, so word problems. Those are fun. Hopefully you had a good time with that. Okay, so in-class practice problems. I want you to do this in class. You don't need to do this at home. If you don't have enough time to finish this in class today, you can let this lesson roll on tomorrow. Okay? So I want you to try number 31 and number 35. Both the answers in the back of the book, but I want to make sure you understand how to do these. You're going to have a quiz when I come back over these kind of word problems. Can you figure them out? Okay? Two good problems. I like these a lot. So take some time, go over those in class. Check them with the answers in the back of the book. Make sure you understand them. If you don't, ask Mrs. T. She'll give you a hand working through those problems. Okay. All right. So after you're done with this lesson, this will be everything for 9.1. So 9.1 is done now. Okay. What I want you to do tomorrow, or whenever you're finished with this particular lesson, I want you to try 9.1 practice B. I printed out copies already. Practice B. Okay, there's copy somewhere around here with the answer key. It's a cumulative, all the problems over section 9.1. I want you to try all of them. Do the best you can. There's an answer key with it, so Miss T can tell you if you're right or wrong, and you guys can check your work. But make sure you know how to do all these, okay? Because we're going to have a quiz over these kind of problems when you come back, when I come back, okay? So that'll be it for 9.1. Tomorrow you can spend the day in class, either finishing this lesson or working on 9.1 practice B, and then the following lesson we'll jump to 9.2 part 1 or part A or whatever we called it. Okay. All right. Hopefully that went well. If you have any problems, just let me know. Okay.